Hello, I'm just going to share this short video about models of current in electric circuits. And this is a simple circuit here. You've got a cell up at the top and a bulb down at the bottom. And fundamentally, the circuit is there to transfer energy from the cell round to the bulb. And it does this by using electrons in the wires. I'm just going to represent this disk as an electron. So the electron, if you like, picks up energy from the cell, transfers it round the circuit, drops it off at the bulb. The bulb then releases that into the surroundings as light or as heat, and then the electron continues to go around to the bulb, to the cell, until it picks up some more energy, and this energy is then transferred round the circuit, gets dropped off at the bulb, and then the electron continues to go round and round. In actual fact, it's a little bit more complicated than that because clearly we've got more than one electron in the circuit. We have many electrons all the way around the circuit, represented here by these red disks. And if you like, the energy gets transferred from one electron and it almost like gets given to the next one, and then given to the next one, and given to the next one, and then given to the bulb, and then the bulb releases that energy around to the surroundings. And when the cells run out of energy, then it's like the battery or the cell being run out and no more energy can be supplied to the circuit. That's kind of an idea of what's happening inside an electrical circuit. But we know that's maybe difficult to visualize. Electrons are really, really small and it's not easily clear about what the energy is. So it's sometimes helpful to think about it as a model. And here are a couple of classic models that you need to be aware of. The first one is this idea of a heating system. Up at the top here, I have a boiler that heats up water. I have pipes that carry hot water. And down here, I've got 3 radiators that transmit the energy from the boiler and the heat out into the room. Now, in this model, the boiler is a bit like our cell. The pipes are a bit like the wires, and the radiators are a bit like bulbs. And the water inside the pipes, well, that's like our electrons. So the boiler heats up the water, like passing energy to an electron. The water is then pumped round the circuit, and the energy is then given to the radiators or the bulbs, and then that heat is transferred from the radiator out to the surroundings into the room that you basically want heated up. And then slightly cooler water will then run round the pipes, get warmed up by the boiler, and the process repeats. It's a pretty good model because we can make equivalencies. We've got a boiler, which is a cell, and pipes and wires, and water and electrons, etc. But in this model, if we were to break one of the pipes, then the water would leak out and you'd end up with a big mess everywhere. But that's not what happens with electricity. If we have a break in the wire, actually the circuit just stops and there is no leakage. But fundamentally, the circuit idea in the model is very, very good. We can also think about it as one of my favorites, thinking about a pizza factory and a party at a house. And here we have the pizza factory or the pizzeria making pizzas, and these pizzas are delivered to dispatch riders who then carry the pizzas around the circuit and drop them off at the party, and then they're consumed and the energy is used up. And then the pizzeria maybe make up a new pizza, and that gets sent round by delivery drivers. And you can see on this side, we've still got riders, but they're not carrying a pizza. If you like, these guys are all carrying the pizzas round. We've got a pizza each as the pizzeria and the deliveries keep on coming. But once they've dropped it off at the house, and the next rider sets off, then the riders return to the pizzeria kind of without that energy. And this is the idea, similarly, that the pizzeria is a bit like our cell. The road is a bit like our wire. Our riders are like electrons, and our house or our party is a bit like the bulb, using up that energy or consuming the pizzas in this case. So it's a really useful idea to think about what's actually happening. Obviously, the riders are a bit like electrons, and they continue to go round and round and round, always following the same direction. But once they've dropped off their pizza, they return back empty-handed. I hope that's been helpful, and how we can think about how energy is transferred from a cell to a bulb. The current would go in this direction, the current would flow in this direction using wires and electrons. And hopefully it's easy to see how this is very similar to the boiler and the heater model and the pizzeria model. Thank you for listening.